I'm Anil Kumar, and here is a thinking question relating to trigonometry of right triangles. The question is, a ship sails north in strong wind and arrives at a point that is 30 kilometers east and 20 kilometers north of its original location. If the ship is to take a direct route to its destination, what angle, rounded to one decimal place, must the direct path make with the north direction? I'd like you to pause the video, read the question properly, answer, and then look into my suggestion. Now, for solving such questions, first we need to sketch the diagram and understand the situation. So let me sketch kind of a bigger diagram here. So when we say north, we normally take y-axis as north and x-axis we take right side as east. Now in this particular situation, let us assume that that's the destination, right? Now it says a ship sails north in a strong wind and arrives at a point that is 30 kilometers east. So the point which is reached is 30 kilometers east, so 30 kilometers east and 20 kilometers north and 20 kilometers north. So that is the point where the ship arrives, let us say. Right? So this point, let me write this as here, from here to here it is 30 kilometers, right? And 20 kilometers. Okay. So that is how we get our triangle here. So we can make a triangle here, kind of like this. I hope that helps. Okay. Now the question is, if the ship is to take a direct route to its destination, what angle, rounded to one decimal place, must the direct path make with the north? Now, with the north, what is the direct path from this position? So the direct path from north will be, it has to go back kind of like this. Do you understand? That becomes the direct path from the north. So we need to find this big angle. So that is your question, okay? Now you can pause the video since you understand what to find. Answer the question and then look into my suggestion. Okay. Now first is, what we can do here is that we know this much is 180 degrees. Now we could add that angle to find. So if I have to first find, let us say, this angle. Let us first find this angle. Let me call this angle as theta. Then I'm looking from that side, so opposite side is 30 and adjacent is 20. So I can use tan theta equals to opposite over adjacent, right? So in this case, tan theta's opposite side is 30, so let me write 30 here and adjacent is 20, adjacent 20. So now we can find what theta is. Theta is tan inverse of 30 divided by 20. You could write 3 over 2 also. Okay, so let's use the calculator. Find this angle. So shift tan inverse 3 divided by 2 bracket close equals to 56.3. So we found this angle to be 56.3. Now the ship has to go back, right? So if the ship is going back, then the angle from the north it makes will be 180 plus theta. Do you understand? So the angle from north to return will be how much? So let's call this angle as phi. Okay. So yeah, these are Greek symbols. Okay. So angle phi to return will be 180 degrees plus 56.3 degrees. Okay. So we can add 180 degrees to this. So we do plus 180 equals to 236.3. So we get our answer as 236.3 degrees. So to return to the destination, let us say this was the destination, but it reached somewhere else, right? So it reached R, it has to come back. So from north, it has to take that angle to come back, right? I hope you understand how we did it. And it was kind of simpler to go with this angle rather than calculating that angle and then working our way out. So at times you may have to look from the other side to solve such a question. I hope that helps. Thank you and all the best.